Right, hello students. Today we will quickly discuss the contents of false position method because we have already gone through the concept of bisection method in detail. So I am sure that you will be able to understand the false position method very easily, very quickly. Now please look at this picture. What is happening in this picture? You have a function f of x. Okay, for every question a different or a unique function will be given to you, and we will ask you to find the root of this function. By this I mean to say that find the point where this graph touches the x-axis. If I'm going to use a false position method, I will give you the initial inputs for xl. Xl stands for the lower bound, xu stands for the upper bound. Okay, these two values will be given to you, f of x will be given to you, and the question is that find xr. Now the algorithm for false position method is designed with the help of the distance formula. I believe you have learned distance formula when you did calculus. So if you make this triangle and apply the distance formula, you can end up with this formula, right? So how do you read this formula? XR, the desired root, is equal to the difference of XU, the upper bound, minus the functional value at the upper bound times the length of the interval XL minus XU divided by the difference between the functional values at the lower bound and at the upper bound. By now you are aware how to find the functional values at the given data points. I have checked your assignments and you have done a wonderful job. Very good, excellent. Now students, let us solve a question together and let us go through the class task that I have given to you. Now you can see here that we are going to solve the same function. Let me show you the function. During my lecture, one of the students said that I did not mention the function in the video. Please look at this function. Now, most of you, I believe, half of you are electrical engineering students and then the computer science students. So you better install MATLAB. It is a very helpful software. If you cannot install MATLAB, no problem. Bring a calculator, notebook, and pen and write on your notebook this constant divided by x times 1 minus exponential this big constant times x and bracket closed minus 40, and the function is given to you here in the book as well. Okay, in example number 5.1 it is given to you, and I have typed here in the MATLAB language. It helps me in calculating the results. That is why I have typed here in MATLAB. Okay, and please go ahead, install it. When you can install WhatsApp, Facebook, and so on, why not? Something good for your education, so please do install it. All right, now let me get back to work. Now I'm saying that we were talking about the function. Okay, this is the given function. I have asked, this will be given to you in the exam. One function, the lower bound, the upper bound. For this function, the lower bound is given to you as 12. The upper bound is given to you as 16. Now I want to find the functional value at 12. Okay, then I want to find the functional value at 16. Okay, then you can see the function changes its sign at the endpoints. This means that mean value theorem holds, the root exists. Now you will not divide the interval. This time you will use the false position method. So you will use the false position algorithm or the formula. All right, got the point? So please remember that this time you will use this formula. So XU, the upper bound, which is 16, you will substitute it here. XL, which is 12, substitute here. 16, substitute here. The functional values that I have just shown you now, I have just showed you now, you will substitute these values here. Have you got my point? Now you will substitute the data here and you will get the XR, approximate root. All right, so you can see here it is very straightforward. 16, 12 minus 16, and the functional values that we have just got here, you can see. And from where did I get it? I have obtained these functional values from this formula. And from where did I get this formula? From example 5.1. Book is with you. All right, I've already shared with you the book. Right, so now students, what will happen next? I will now document the values here. I have got 12, I have got 16, and XR that I obtained with the help of the false position formula. Okay, this time I've used a formula. I have not added these two numbers and divided it by 2, but I've used a formula, right? And I have obtained 14.9113. Okay, so now I want to select again the same strategy, students, but this time you can see that these are not equally spaced because this is not the midpoint. Okay, this interval size is not exactly equal to let me show you the other interval, not exactly equal to this interval size, right? So the question is that what will happen next? Which interval to select? The same strategy, functional value at 12, functional value at 14.9113, multiply it, check if it is less than 0, then you will select this interval. All right, so because you have already done the assignment, so I'm very confident that you've got my point. So you have multiplied these two values, the functional values, you've got a negative number, you will select this interval. Again, you will go to the next iteration, you will say your lower bound is 12, your upper bound is 14.9113, and you will delete this part. You will say that I am going to discard this part. Why? Because here the function does not change its sign. F of 14.9113 times f of 16 was greater than 0, whereas here we have got f of 12 times f of 14.9113 less than 0. I will keep this interval. Now I will apply again the algorithm. This time the algorithm has been changed. It is called false position method. So what will you do? You will use the formula. First, you will substitute the XL and the XU values, then the F of XL and F of XU values. Update your XL and XU. X lower, X upper, and with the help of these values you will obtain XR. And what is this? This is the formula. Formula is given to you on page number 132 here, equation 5.7. So I suggest learn it by heart, the formula. Otherwise you can learn the derivation. Simple distance formula is used here for this triangle, and we can see that XR is the approximate root. We are saying that maybe the graph touches the x-axis at this point, but this is not true. Actually the graph touches the x-axis at this point. So we will repeat the procedure. We will apply, we will implement the algorithm again for the third time. This is the homework. This is the homework, and you will upload it on CU Online. Now give me X3. Okay, so you can see that the actual answer, this answer is going very close to the actual answer very quickly as compared to the bisection method. So thus convergence speed is better. You can see that the false position and the bisection method performance. So we can see from this picture false position is better. Now I have asked you in the assignment, please justify which method is better. So please read example 5.6. I repeat, we have gone through bisection method. Now we have gone through false position method. Go through example 5.6, discuss it with me during the lecture, and I will be more than happy to answer. All right, hope to see you. Thank you.